Guys, in this video we are going to see an example of second order circuit. Here this question is asking, find this current I of t in an RLC circuit with R is equal to 15 ohm, L is equal to 0.5 henries and C is equal to 10 to the power minus 2 farad, which is connected to a source of EMF is equal to 115 sine 377t. Assume that current and capacitor charge are 0 when t is equal to 0. Okay, now let's go ahead and draw the circuit for this one first. The circuit is going to look like this. Okay, let's use different color. Okay, this is our circuit, and in the circuit we are going to have voltage source, and also we are going to have the resistor, inductor, and also the capacitor. Okay, and the voltage source is going to be the given EMF, that's equivalent to 115 sine 377t. Okay, and also we have the resistance provided, that's equal to 15 ohm, so this is 15 ohm, and after that we have the inductance provided, that is 0.5 henries, and after that we have the capacitance provided, that is 10 to the power of minus 2 farads. Okay, so this is our circuit. Our purpose is to find the current through this one. So let's say the current is going in this direction. Let's call this one I of t. So this is what we are trying to find. Okay, the first thing is we are going to look at the initial conditions, and here they have mentioned initial, that when the time is equal to 0, the current and the capacitor charge are 0. So we can say I of 0 is equal to 0, and also we can say I prime of 0 also equal to 0. So these are the two things we need in order to derive the final answer. We are going to use this one later. And also when we derive, here we are going to derive the second order differential equation, because this is a second order circuit, right? We know that this is a second order circuit by looking at the energy storage devices. When we have two energy storage devices, here we have inductor and capacitor. By looking at these two, we know that this is a second order circuit. And when we have second order circuit, we have to derive a second order differential equation in order to solve the problem. Now, in order to do this, we have to know these two important equations. First of all, we have to know that I of t can be replaced with C dV of t over dt, and also we can replace VL with L dIL of t, or we can say di of t, because since this circuit is in series, the current through this one is going to be same everywhere, right? So we can say di of t over dt. Okay, so these are the two important equations we have to know in order to bring the second order differential equation. Okay, it depends on the case. Like here we are trying to find the current, so we will just switch this equation, like we will change this according to current and bring the equation to bring the differential equation in terms of current. If it's voltage, we try to bring everything in terms of voltage. Since they are asking for the current, we are going to bring everything in terms of current. Okay, now let's go ahead and bring the differential equation. Now in order to do that, first we are going to apply Kirchhoff's voltage law. So that's way we can derive an equation, right? So since the current is going from negative to positive, this voltage source is going to be negative in our equation. That's going to be negative 115 sine 377t, and after that this current is going through this resistance, so this is going to be plus 15 I of t, and after that this current is going through this inductor, and when the current is going through the inductor, we can replace that one with this one, L di of t over dt. L is 0.5, right? So we can say 0.5 di of t over dt. Okay, and after that this current is going through this capacitance, so we can say, so we can rearrange this equation. Let's go ahead and rearrange this equation first, because we have to express this current in terms of the voltage. So if we rearrange this equation, this is going to become I of t divided by C. Okay, I of t divided by C times dt is equal to dv of t, and if we integrate this one, we can get v of t. Okay, so v of t through the capacitor is going to be equivalent to 1 over c. I can move it to the front because 1 over c is a constant. 1 over c integration I of t dt. So instead of this voltage across the capacitor, I can write this one as integral of, like 1 over c integral of I of t dt. So that's what I'm going to replace right here. I'm going to put 1 over c integral I of t dt. Okay, that's equal to 0. Addition of all the voltage is equal to 0. That's a Kirchhoff voltage law. Okay, now what we are going to do is, to get rid of this integral, we are going to take the derivative everywhere, and if you do the derivative for this sign is going to become cos, and also we are going to have the inside derivative. In that way we will get negative 115 multiplied by 377 and cos 377 t, and this is going to become plus 15 di of t over dt, and this one is going to become 0.5 di prime divided by dt, and this integral is going to cancel, because when we take the derivative, integral and derivative cancels each other, so we are going to have I of t divided by c is equal to 0. And the next thing is, we are going to keep I terms in one side, and also we are going to bring the others to the other side, and let's do that one right here. Here this whole term is not dependent on I of t, right? So we can move this one other side of the equation, and also we are going to write this one in decreasing order. So instead of di prime mean I double prime, right? So we can write this one as I double prime 0.5 I double prime. After that, the first order, this is second order, then first order, that's going to be 15 I prime of t. So let's put t, I prime of t, and after that we have I of t divided by c, I of t divided by c, and we know the capacitance. We can plug the capacitance right here, that is 10 to the power minus 2, and if you divide this one by 10 to the power minus 2, when it goes to the top, that's going to be 10 to the power of 2, so that's going to be 100 I of t. Okay, so let's write this one clearly. So this is going to be 100 I of t, and in the other side of the equation we are going to have this one, and if we move this one to the other side of the equation, this is going to turn into positive, because if we have a negative sign, that's going to turn into positive. So we are going to have 115 times 377 cos 377 t. Okay, so this is what we are going to have, and that's it for this one. Now we are going to find out our characteristic equation. Because this is a non-homogeneous differential equation, we are going to use the superposition technique to bring the general solution for the non-homogeneous differential equation, and the superposition technique says that general solution for the non-homogeneous differential equation can be calculated by finding the homogeneous solution and also finding the particular solution and adding them both together. Okay, to find the homogeneous solution, what we do is we equate this one to 0 and we write our characteristic equation. In the characteristic equation, I double prime is going to be r square, and the coefficient, we keep the coefficients, so this is going to be 0.5 r square, and then 15r plus 100 is equal to 0. And if you solve for r, you will get r1 is equal to negative 10, and then you will get r2 is equal to negative 20, since we have two distinct real roots. So when we have distinct real roots, that's going to be overdamped system. Okay, so this is an overdamped system. So general solution for the overdamped system, so we can write a homogeneous solution. So let's say V homogeneous for overdamped system is going to look like this: C e power, we put the first r, that's going to be negative 10t, plus C e power negative 20t. So we call this one C1, C2, okay, two different constants, and this is going to be a homogeneous solution. Now we have to find the particular solution. Now to find the particular solution, let's get rid of this part, because now we brought the differential equation, we don't need this one anymore, but when we apply this one we need, but for now we don't need this one. Let's get rid of this one. Okay, so let's get rid of this part. So this is our homogeneous solution. Let's box this one here. This is our homogeneous solution. Now we are going to find our particular solution. To find the particular solution, we since we have underdamped system, particular solution is going to look like this: A cos omega t plus B sin omega t. Now here we have to find our A value and B value. In order to find the A value and B value, we have to find the reactants. The reactants can be calculated by subtracting capacitive reactants from, like, inductive reactants from capacitive reactants, right? Actually, capacitive reactants from inductive reactants. Inductive reactance is given by omega L minus capacitive reactance is 1 over omega C. In our case, omega is 377. We know that by looking at the given voltage source. In the voltage source, we have the value that multiplies T. That's our omega value. That's 377. So this value. Okay. So 377 multiplied by the inductance, that is given by 0.5 minus 1 over omega C, that's going to be 1 over 377. Given capacitance is 10 to the power minus 2, so we multiply this one by 10 to the power minus 2, and if you calculate this one, you're going to get 188.23. so this is going to be the reactants. Okay, so after we find out the reactants, we can calculate this A and this B value, because we already know the omega value. Omega value is going to be the 377. Now to find the A and B value, we are going to apply this one, because A value is given by this equation. A is equal to negative E naught S over R square plus S square. Okay, negative E naught. E naught is 115, this amplitude. That's our E naught. Okay, so 115 multiplied by this S, that is reactance. That's going to be 188.23 divided by R square. That's going to be the resistance square. That's going to be 15 square plus S square, that's reactance square, that's going to be 188.23 square, and if you calculate this one, you're going to get negative 0.607. Okay, so this is our A value, and after that we are going to calculate the B value. To calculate the B value, what we do the same equation, but this is going to be positive in this case. Also we are going to have R, so this is going to be E naught R divided by, the denominator is going to be same, that's going to be R square plus S square, and here E naught is the amplitude of the given voltage, that's 115, and then R is going to be the resistance, so this is going to be multiplied by 15 and divided by the same denominator, that's going to be 15 square plus the reactance square, that's going to be 188.23 square, and that's going to give us 0.048. so this is our B value. Now we have the A value and the B value, so we can write our particular solution. Okay, so for the particular solution for this differential equation is going to be let's call this one IP. This one should be IH, right? We are finding current, so this one should be IH, and IP is going to be A cos omega t. A is negative 0.607 times cos omega is 377. Okay, so this is going to be 377 t plus B is 0.048, then sine omega t, omega is 377 t. Okay, so this is a particular solution for the homogeneous differential equation. Particular solution. Okay, so the general solution for the non-homogeneous differential equation is going to be addition of this homogeneous solution and the particular solution. Now let's go ahead and write that one. So let's get rid of these parts. Okay, so here we are going to write our I of t. Therefore I of t is going to be IH plus IP, and we found out IH, that is here we boxed right here, I of h, that's C1 e power negative 10 t plus C2 e power negative 20 t, and IP is this one, so we are going to write all together because IH plus IP. Okay, this one IP, so this one is going to be negative 0.607 cos 377 t plus 0.048 sin 377 t. So this is going to be our general solution for this non-homogeneous differential equation. Now we have to find the particular solution for this non-homogeneous differential equation. Now to find this one, what we have to do is we have to find out this C1 value, and also we have to calculate this C2 value. So in this situation we are going to apply our initial conditions, and one of the initial conditions say that I of 0 is equal to 0, and if we apply 0 for this current and I of 0 is equal to 0, so we can say 0. At that time what's going to happen is this e power negative 20, this is going to become 0 because t is 0. So this is going to be e power 0, that's going to be 1. So we are going to left with c1, and this c2 remains because this is going to be c2 multiplied by 1, again c2 e power 0, because negative 20 times 0, that's going to be 0. So this is going to be just c2, and then here we have 0.0607 cos 377t, and this t will become 0, therefore this is going to be cos 0. Cos 0 is 1, so 1 multiplied by this negative 0.607, that's going to remain. So this is going to be negative 0.607, but here we are going to have sine 0. Sine 0 is equal to 0, so this one doesn't come, right? So this one will be eliminated. Now the next thing is we are going to take the derivative of this one. Let's go ahead and do that. If we take the derivative of this one, this is going to become, let's get rid of some of this part. Okay, let's get rid of this one. Okay, so here we are going to take the derivative. Okay, so let's go ahead and take the derivative. If we take the derivative of this function, we are going to have I prime of t, that's going to be equivalent to this inside derivative is going to be negative 10. So negative 10 c1 e power negative 10 t plus negative 20, so we can get rid of this plus right here. It's going to be negative 20 c2 e power negative 20 t, and then we are going to take the derivative of cos. Derivative of cos is negative sign, so negative sign, this is going to make this one positive sign. So positive sign, that's, and we are going to have 0.607, and also we are going to have the inside derivative. Inside derivative of this one is going to be 377. So 377 multiplied by sine 377t, and after that we are going to take the derivative of this sine, and that's going to be just plus cos theta, but we are going to have the inside derivative again, so because this is also chain rule. So here we are going to have 0.048 multiplied by 377 sine, actually sine will turn into cos, so this is going to become cos. So here we are going to have cos 377t. Okay, now we are going to apply the second initial condition. Second initial condition says that I prime of 0 is equal to 0. So directly we can plug 0 right here because I prime of 0 is equal to 0. So we put 0 right here, and also we are going to plug 0 for all the time in our equation. So for this, the first one, we are going to have negative 10 c1, because this e power negative 10t will become e power 0 because this t is equal to 0. So if you multiply negative 10 times 0, that's going to be 0. So e power 0 is equal to 1, so we can eliminate this one. Okay, and this one is going to be negative 20, and also here we are going to have sine 0, and sine 0 is equal to 0, so the whole thing is going to be 0. And here we have cos 377t, and this t is going to be 0, and we know that cos 0 is equal to 1, so we are going to have 1 right here, so this term will remain. So we are going to have 0.048 multiplied by 377, and from this one we can calculate for c1 because we only have one unknown variable, so we can solve for c1. And if you rearrange this equation, you're going to get c1 is equal to, okay, 10 c1 is equal to 5.96, and if you solve for this one, you will get negative 5.956 divided by 10, and you will get c1 is equal to negative 0.5956. So this is our c1 value. Now using this one we can find out our c2 value, because initially we made a connection between c1 and c2. If c1 is this one, then c2 is going to be equivalent to c1. Okay, let's create the equation. C2 is going to be equivalent to, okay, if I bring these two to the other side, 0.607 minus c1. Okay, so this is the connection. Now we can write the equation 0.607. Since the c1 is negative, make this one plus, right? Because c1 is equal to negative 0.5956. So here we already have a negative, that's going to turn this one into positive. So we are going to have 0.5956, and if you add these two together, you're going to get 1.2026. So this is our C1 value and this is our C2 value. Now we can go ahead and write our particular solution for this non-homogeneous differential equation. That's going to look like this. Okay, that's going to be our final answer. Now let's go ahead and write that one. Let's write this one right here. So this is going to be, but we are going to need a big space. Okay, so let's move this value to the top. So 1.2026, C2 is equal to 1.2026. Now we are going to write our final answer. That's going to be I of t is equal to C1. C1 is equal to negative 0.5956 e power negative 10t, then plus C2. C2 we calculated, that is 1.2026. So this is going to be 1.2026 e power negative 20t. Then after that, other things are just going to remain the same. So that's going to be negative 0.607 cos 377 t plus 0.048 sine 377 t ampere, and that's going to be the current through this circuit. I hope this helps. Thanks for watching.